Okay, so we said that we already grouped the members and also we assigned the support. And now we want to assign the sections to members, column member, beam, and rafters, and let's say purlins. So to do so, I will go to bar, and then here I have the describe option. So let's go to describe. Okay, so if you remember, by default we accepted, the concrete section. But for now, I will select the external columns and also internal columns. Okay, so just click on these two columns. So the rest will be selected because we already grouped them. Okay, so once the selection done, you need to approve it by right click. Okay, just right click. And then here we have the sections. So right now is concrete. So I will change it to rule the steel section. Okay, and from here, I'm going to select the I-beam section. If the library is empty for you, okay, just accept this, and then you can use this. After selecting the members, you need to do right click.
Pilih column. Column dalam. Itu right click.
Okay. Okay, and now change to this one to rule the steel section. Okay, and then here we have the I-beam. So if you don't have any section library, so you can use this option. If you have, so just select the UB section. Okay, but for now, for me, I don't have this one. That's why I will go to edit the list of elements, this one. Okay, just click on that, and then the last one. Okay, so I will click on this, and then I will go to European section ranges. Okay, and from here, I want to bring the, for example, UB sections. Okay, accept. As you can see, so I have the UB series with all the sections that I need. By the way, if you want to create your own library, if you want to edit the sections, so always you can go to edit option. You see here, you have the edit option. And from here, you can, let's say, edit any of this section. For example, here, I can select this one. And here I can make a copy. You see here, I have the copy option. And then the last one. And from here, I can go to edit. If I click on edit, you see here, you can change the dimension of this member if you need it. Okay, but for now, I'm not going to, let's say, do this. Okay, so let me select the a section for column. I'm using the UB, so it is up to you. You can also select the UC as well. Okay, but for now, I want to use the maybe this section 533.165.66. Okay, so I'm going to select this or accept this. Sorry, once again, here 533, the first one, 533.165.74. Okay, and then accept. Do not consider fire situation, accept. So now you can a little bit zoom in, and here you can see the column section that you have. So for the rafters, still the command is active. I will select the one of the external and internal rafter. The rest will be selected automatically. And again, for approval, I will do right click. Okay, again, from concrete, go to steel. Okay, from here, I will select UB. So for column, I selected 533, but for beam, I'm using the UB 457.191.106. Okay, or maybe I can use the with deeper section. Okay, maybe I can use the 610.178.82. Let's use this one, 610.178.82, and then accept. So here also I have this section. And for tie beams, so just select one element, already we grouped them. Again, for approval, do right click, go back to IBeam, UB. I will select maybe 178.102.19. Okay, 178.102.19, and then accept. And for the purlins, again, just select one purlin and right click. So I will come to cold form this time, come to cold form. And from here, maybe I want to use this one. Okay, so this, I don't have any library, so I will import it. Again, I can go to here, the last one. Okay, and again, so here I'm going to bring maybe one of these sections. Let me try this. Okay, so here I can go for, let's say, 80 by 50 by 20 by 2. If you want to understand about this, always you can go to edit option. And the thing that I select is this one. And you can go to edit. Okay, so here you have the 50, 80, and then here you have the 2. Okay, and this one is 20. So from here to here is 20. You can change it if you want. Okay, so I'm going to select this section, accept, and if you zoom in, so here you can see the purlin section. So now we assign all the section, as simple as that. And then, so if you want to see the render view, you can go to the tools. Okay, and then here you have the 3D view. So for 3D view, you can go for complete structure, active window, or element selection. So what is active window? So let me show you before going to show the render view. If you go to the window, as you can see, select any section, doesn't matter.
Can you repeat at the purlin size?
For the purlin, okay. So you need to go to the bar, describe, and then select the purlins, right click. Okay, go to the cold form. And from here, I'm selecting this C section. And from here, I selected the C80 by 50 by 20 by 2.
We need to edit 80 times 50.
Don't worry. No, you don't need to edit.
Okay.
Okay, go to this option, the last one. Okay, and then here you have this, okay? Click on this one, import of predefined sections, okay? Just click on that. And then from here, yeah, you can select this one, okay? Institute, I don't know, Argentino the blah, blah, blah. Okay, and then just check this option and then accept. Okay?
Okay.
And again, from here, accept. Okay? So now you need to select, the C section that you defined right now. And then, so you can come to this. Done?
Wait. Okay, delete yang lama. Right click Okay.
Okay.
Okay, done?
Yeah.
Okay. So, and then so accept. So here, just you need to accept after selecting this section and then accept.
Right.
Okay. So now you can little bit zoom in, and here you can see the section. Okay. Okay. So now we were talking about the render view. So I said that if you want to see the render view, so you need to go under tools. And here you have the 3D view, but here you have three options: complete structure, which means entire structure, active window, and element selection. So if you go to, let's say, complete structure, click on that, complete structure. So here you can see the number for structures. Okay. Close that, just close it. So again, go back to tools, 3D view, and then here you have the element selection. Okay, go to element selection. For example, here I can select this element, and this element, and maybe one of this. Yeah, one of this rafters. Okay, so element selection. So I will select rafter, column, tie beam, and one of the purlins, and then right click. Okay, and as you can see here, you have the element selection. Again, close it. But you have another option. You have the active window. So active window, it means that you can create a new window for yourself by going to window tab. So here I have the window, and only I have one 3D view, okay, which is the default one. So if you want to create any 2D view, for example, so I can go to open new. Okay, so here you have different options: 2D view and also 3D view. 2D view in a plane orthogonal to XYZ axis, 2D view of a plane, 3D view of the whole structure, 3D view of a part of the structure, 3D view of a section of elements. So up to you, okay? So for example, here, let me show you how simply you can work with the 2D view. For example, the second one, 2D view of a plane, okay?
Window
Go to window and the first option, yes, new view. Okay, and then you have this.
window.
Okay, so let's select the second option, 2D view.
New opening.
Yeah, 2D view of a plane. Okay, and then accept. So once you accept, here at the bottom again, so you have the instruction. Okay, so it says that you need to select 3 points, okay, to understand the plane. Assume that here I have the inclined, let's say, surface. Okay, I will select the apex point, and then here, okay, and also here, or you can come to end of this here. Okay, doesn't matter. Click, and then here I will say that, for example, purlins. Okay, and then accept. So you see here, you are in the 2D view. And then here you have the window, you have the tile horizontal, tile vertical. Okay, so let's go, for example, tile vertical. So I can see actually, both windows. Okay, and if I do anything to this window, so you see actually, the effect here in 3D. Okay, so if you want to create different windows, okay, so don't close them using this option. If you close them, so which means right now here under window, as you can see, I have the 3D and also I have the purlins. So if I close this, okay, so this purlins will be gone, okay, will be removed. So that's why I always use the, let's say, maximize and minimize option. Okay, so for example, here I can maximize this, or simply I can go to 2D let's say plane, which is purlins, and then maximize. Okay, so now if you go back to tools, 3D view, and then you have the active window. So right now, this window, the 2D window is active window. If I click on that, you see only purlins will be shown. Okay, and then close. If you want to go back to 3D view, you can go to window, and again here you have the 3D. Just click on 3D. Okay, you can come back here. Again, if you will go back to 2D, just click on this. Okay, so just like this, you can shift between the views that you have. Let's go back to 3D. So now let's talk about another topic, which is offsets. Okay, so if I go to tools, again, 3D view, complete the structure. Let's look at here and discuss about this. By the way, here in render view, you have different options. For example, the first one, you can see here elements. Okay, just click on that. And right now, only I have the column and beam. Okay, go to elements, and then I have the column and beam. So from here, you can hide the, just click on the
3D. Okay.
Or in another, you can, for example, right now, solid, so transparent view of the column and also transparent view of the beam, or you can go to wireframe view and also wireframe view.
Oh, select.
Okay, so you have different options. So let's go back to solid view. And here you have the next option. It is actually again information icon.
Okay, so bawa sama saya ni.
You can click on this. You can click on information option here, the I option. Just click on that. And then so you can come to, for example, this column. You see here, the column will be highlighted. And then you can double click. Just double click on that. And then so you will get the information of that column. Okay, you can come to, for example, this purlins, double click, and then here you have the information for this member.
Okay.
Okay, so you can just again click on I option to deactivate it. And so here also you have the sections, these three options here. Okay, so you can create the section in X, Y, and Z direction. So if you click on this, you see here, you can create the section in this direction, okay, in Y direction. If you want to exchange the view, you can come to this option, or let's say, you know, this arrow, and then double click, just double click, okay, and it will be in this direction. You see here. Okay, and also in Z direction here. Okay, so this is actually no render view, and at the bottom side, so here also you have some other options. For example, you can bring the ground for better visualization. So you can do left click to rotate your model. And also you can see the structure, you know, based on the material. So if you, let's say, check the material, so everything will be red, which means all of them are steel. Okay. And also you can uncheck material. And also you have the object edges and also improve environment length. Okay, so let me just uncheck the ground. And here I want to talk about one thing. So in every software that we are using, so they are following the center line. So here I have the common nodes between this column, which is actually now the center line of this column. This is the center line of this tie beam. And here also I have the center line of this, let's say, rafter, which pass through the center line of this purlins. Okay, so everything is based on center line approach. But in reality, we have actually something like this, because here I have this rafter, and the rafter actually now should be somewhere here, you know, to provide the end plate, and then here I want to put the bolt or whatever I want, right? And also the purlins, for example, should be at the top of the rafter, not somewhere here. Okay, so that's why you can use the offset option in this software. Okay, so let's see how simply we can offset the members. Okay, so for offsetting, I can go to the bar again, and here you have the describe disposition. Okay, describe disposition here. Okay, click on that. And from here, maybe I can go to this YZ view. I want to select all the top members. Okay, so all the top members. Okay. Okay, you see right now, here you have the local coordinate system. So you have the local coordinate system, which is exactly at the center of the sections. Okay, so that's why we are saying that, you know, they are following the center line. Okay, so here it is the beam, and here it is the center of the beam, and the node will be placed here. So we need, if we want to shift down the member here, so we need to shift the local coordinate system at the top. Okay, so the coordinate system should be here. Okay, and then the member will be shifted down. So once again, for any member, doesn't matter. For example, here I have the I-beam, and here I have this C section. Okay, so I'm going to draw it here. So I have this one, and also I have this one. So for any member, doesn't matter. So we have 9 points. Okay, so here 1, 2, 3, 1, 2, 3, 1, 2, 3. Similarly here 1, 2, 3, 1, 2, 3, and then at the bottom also 1, 2, 3. So for the top, I have the top left, top center, top right. Okay, middle left, mid center, mid right. And here I have the bottom left, bottom center, and bottom right. Okay, similarly here, so you have the exact same thing. So that's why here you can see, so here the nodes is here exactly, you know, at the mid center. And also if you look at the purlins, you see here, so the local coordinate system is passing through this point. Okay, so if you want to shift them down, so we need to select the top center, and then so the new location will be something like this. Okay, so it will be something like this. And the local coordinate system will be here. Okay, so let's see that. Okay, so already we selected, already we selected all the top members except columns. Okay, and then for approving, right click. Okay, so now here we have it. You see again, here I have the local coordinate system, which is exactly at the mid center. I have let's say 9 nodes. You see here, 9 points. So now I need to select the top center. Okay, if I select the top center, you see the local coordinate system will be located here. If I select the bottom center, so the local coordinate system will be placed here. So let's go to this one. top point. So once you select the top point, so the member will be shifted down. Once you select the bottom, which means here, the member will be shifted up. Okay. So for this, I want to select the top point, center or top center. Okay, and then accept. You see here you have the dot lines, which means you have the offset. So now if I once again go to tools, 3D view, and then complete the structure. Let's go there and see what happened.
Right-click jadi tengok perli atas.
Okay, you see here,
Right-click jadi.
shift it down.
Oh, right-click jadi. Jadi naik atas. Kata naik 3D, terus 3D naik ke atas.
Yeah, go to tools, 3D view, and then
Tool.
complete.
Oh, ada mana? Complete. Terus dia naik atas. Right-click.
Okay.
Tak ada mana dia. Saya cik jauh. Wait, 5 minutes.
Okay, so I will repeat. Go to tools, 3D view. Okay, here 3D view, and then complete the structure, the first one. Complete the structure. Just click on that.
On the top of IB.
Yes. Okay. Now you can zoom in here.
How to
Done?
The step to put the perlin on the top of IB.
Yeah,
you
yeah.
repeat?
I will do that. Don't worry.
Okay.
Okay. So right now here, as you can see, we have actually the common node, which is here. So right now the common node is here. Okay. And right now, so it is actually the top of the rafter and top of the tie beam. Okay. And here still I remain the column at the center. Okay. But as you said here, since we shift down everything, so which means I also I need to put the purlins here at the top. So what I need to do, so here assume that you have the purlins, and then so if you select the bottom center, okay, so the purlin actually will be shift up, and then so the new location will be like this. You need to select the bottom center. Okay, so let's do it. So I will close this, and from here I will go to again bar, describe this position. Maybe I can go to bar, describe this position. Okay, and then from window maybe I can go to 2D purlins. Okay, is much easier, and then so I will select this purlins just like this. Okay, and once you selected the purlins, you need to do right click again. You see, for this purlins, because we selected everything as top center. So right now, simply I can select it as bottom center. Okay, just bottom center. Okay, just bottom center, and then accept, and then accept. Okay, accept. So once you accept it, again you can go to the tools, 3D view, and then complete the structure once again. So here you can see that the purlins are at the top of rafter. Okay, but here you have something, so which means the angle of the purlins is not exactly at the angle of the rafter. So you can also correct this as well. Okay, so for correcting this, done. Okay, so here I have 8 meter, and here I have 1.6
Anak
meter.
bawah tekan sini.
And I need to find the theta angle. So simply I can say that inverse tangent 1.6 over 8. So if I calculate this, okay, so we have the 11.3. Okay, so here I have the 11.3 degree. Okay, so simply again, I can go back to the purlins. Again, bar, describe this position. So I will select the purlins, just like this. Okay, and then you right click. So if you want to rotate it by 90 degree, any member, okay, it can be column, it can be beam, or let's say purlins. Okay, so by 90 degrees, so you can use this option by 180 and also minus 90. And if you have any free angle, so you can come to alpha. Okay, so here we said that the angle is 11.3. Okay, so simply I can, let's say, rotate it just like this and then accept. So once I accept this, again, I can go to tools, 3D view, complete the structure. And here I should have the perfect placement. Okay, so here you can see that. And then again, I can close it. Okay, I can come back to 3D view. This is for offsetting. Okay, so after creating the elements and assign the sections to them, so you can go to, let's say, if you have any walls, so you can create the
Ini ya, kita nak
shells.
tengok again ya, pilih tengok kat
Apa ni
atas.
dah? Dah macam awal tadi.
Sebab kat Jawa. Itu susah mata itu.
Yeah, please let me know if you have any question or difficulties.
Share.
Okay, so can we go to share? Yeah. So after let's say you've done with the elements or bar elements under here. Okay, so you can go to shell. Okay, so for shell you can create the, for example, I don't know, walls or roof. What I say, steel roof, concrete ground floor, walls. Okay, but once you are using shells, so you can get the analysis result. Okay, and based on the analysis result that you have, so you can design the walls or slabs. Okay, but if you want to design the slabs or, for example, mat foundation, so here you can go to Cype software. Okay, in Cype you can design the slab, different type of slabs. For example, joist pillar slab. Okay, so joist pillar slab, hollow core slab, fillet slab, buffalo slab. Everything is there according to selected codes. Okay, and so also mat foundation. If you want to design the mat foundation only, so you can go to Cype. But other type of foundation like combined footing or isolated footing, pile cap, still you can design it in Cype 3D. And also, let me show you, this is, you can go to your YouTube account. And this is actually my YouTube channel. Okay, so you can subscribe to this channel, and if you go to playlist, so here you can see that I'm time to time, putting the CypeCAD and Cype 3D tutorials. Okay, and not only that, if you are familiar with StatPro, so I'm also adding the StatPro tutorials as well. So here you have it, okay, and many other solutions, okay? I'm familiar with many solutions, Tekla, SAP 2000, eTabs, Idea Statica, and blah, blah, blah. Okay, so if you subscribe, so definitely you will get the notification for updated tutorials. And from here, I wanted to show you this under playlist. If you go to CypeCAD, just click on CypeCAD, and here I have a video combining CypeCAD and Cype 3D. Okay, so maybe also I can show you during the CypeCAD training as well. Okay, but this one is a complete, let's say, tutorial. And as you can see here, you have the concrete material, and here you have the mat foundation at the bottom. And here also you have the circular column, which is concrete column, and the rest, which means, this section done in Cype 3D, and the bottom side done in CypeCAD. Okay, so you can combine them, and then so you can go ahead. Okay.
Okay.
Okay. The shell element. So if you want to create any shell, so if you go to new shell, new, and then here you have the thickness. Okay, so if you have the concrete, maybe concrete wall, so you can go for 200 mm thickness. If you have the ground slab or ground floor, so here you can activate the subgrade modulus to consider the soil structure interaction. Okay, and if you have the steel roof, so you can change it to hot rolled steel or cold formed steel, or if you have the aluminum, so you can go to aluminum. And if you have any general material, so you can key in the value simply here. Okay, so let me go back to concrete, and then here 200 mm. And if you want to change the, let's say, grade of the concrete, so here you have it, you can change them. Okay, and then accept. Once you accept this, to create the shell elements, so I can start from here. Okay, and I'm going counterclockwise. Okay, so from here to here, and then to here, and then to here. And before closing, so I will do right click. Okay, and then here you have the okay, so I did it actually counterclockwise. Okay, and why I did that? Because if you go for counterclockwise, as you can see here, the z-axis is outside. Okay, so if I want to go for clockwise, you see here, if I continue from here, this node, and then here, and then here, here, okay, and before closing, again, right click. You see here, the z-axis will be inside. Okay, so it is up to you again, but you need to understand actually the local coordinate system of the shell elements, especially once you want to apply the load. Okay, so just to show you something, so you don't need to do anything. So quickly, I want to show you something. You see here, if I go to the load, and then here I have load on the shells. Okay, so if I go to here, I can select these two shells. Okay, let's say under, for example, live load. Okay, select this two, and then so I can apply this load. It doesn't matter what is that. Okay, so I will go to local, and then accept. You see here, so for this one, the load is applying, in this side, and for this one is applying in this side. So that's why you need to, let's say, pay attention to the local coordinate system of the elements and shells. So, but if, let's say, you have many, let's say, shell elements, and it is not, let's say, good to delete everything and recreate it again. So we have some advanced option to change the direction of the coordinate system. So for example, here I can go to the shell, and here I have the reverse, the direction of the z-axis. You see that? So simply I can click on this, and then so click on this shell, and then do right click. And then here you have it. If I go back to the load, if I go to the load and visible load case under live load, you see here right now, I have the load correctly. Okay, all of them. Just give me a moment, please. Okay, so actually I gave you this example just to make sure that the local coordinate system are similar. Okay, so I will undo the procedure. Okay, just I want to have, let's say, this wall, for example, and I want to discuss something about this wall. Okay, so the first thing is meshing. Okay, so if you want to mesh the wall, so we have the analytical mesh. So here you have the discretization. Okay, so by default, you have, by default, you have 1 meter by 1 meter mesh sizes. Okay, so if I click on this, and then you need to click on the shell and then right click. Okay, so here you have the 1 meter by 1 meter. Okay, but here also you have another. You have another option here. You have the divide shell. Okay, so I will show you how simply you can divide shell. You can go to divide.
The value of the discretization.
Yeah, under discretization. So you can select the wall and then right click. And then here you can change the mesh size. Okay, so you can accept it. I want to show you something. So go to shell, and here you have the divide shell. Okay, click on divide. So from any location, don't worry about that. Okay, for example, here I want to accept this, just enter. Okay, and then so I can divide the shell, for example, up to here, and then enter. Okay, you see here how simply I can divide the shell. Maybe I want to divide from here, again, enter, up to here. Sorry. Just give me a second. Sorry, let me just. Okay, so let me go back to the. Okay, so let me. So actually, okay, let me just.
Okay. That's it. Hmm. Tambah ni apa orang dia ni?
Ini
Ini.
tambah.
Kayak nyengok.
Oh, best.
Habis. Kira lebih banyak dia.
Okay, so let me just once again just check the structure. Okay, so I didn't save my model, but let me just quickly create the sections. Okay.
Buka dia yang itu. Okay. Ni.
Sorry guys, so let me just quickly create the sections. So for the column, I used this one. And then for the rafters, I use this. Okay, and also for the purlins, let's say for the tie beams first. Okay, I use the
Medyo may kailangan. Bo. Sakbo.
okay, and also I offset the elements. And for the purlins, okay, I need to do this and also 11.3. Okay. And then, so here, if I go to the structure, so here I have everything perfectly. Okay. Let me save the model. Okay, and now, so we were talking about the shell. Okay, so I want to create the shell, 100 mm, accept. So I was saying that I can go counterclockwise. Okay, and then, so we were talking about the discretization already, I showed you. And then right now we are thinking about the divide. Okay, so for example, here I can divide this shell just like this, or maybe just like this. Okay, so you have something like this. Let's assume that here I want to discretize the shell element. I will go to shell, discretization. And for this one, I will change it to 0.4, let's say. Okay, just I want to show you how simply you can discretize the shell elements without affecting the beams. Okay, and here also I want to make it as 0. For example, 6. Okay, so now let me just quickly run the analysis. Okay, and after running the analysis, if you go to deform shape, okay, here you can see how perfectly you can go for different mesh sizes, okay, without affecting the beams, okay? So I'm saying without affecting the beams, since you are familiar with the StatPro. In a StatPro, if you want to, let's say, rectify or correct the mesh, you need to remove them. And then, so you have, too many small beams that are already divided due to having the meshes, correct? And it is actually no time consuming, but here, simply you can change them. Okay, and also you have the option to join the shells as well. So here you have the join option. Let's say, for example, I want to join this and this, okay? Then right click, again, join this and this, and then right click. Okay, so as you can see, simply you can work with the shell element. I'm not going to add any shell, so let me delete it. If you want to delete, so you can delete the shell, just click on the shell and then remove. Okay, so here I have 3 nodes. Also, I can delete this node, and this node, and then right click. So let's go to the load application. Here you have the load. So first of all, we said that the self-weight will be calculated automatically. If you want to see the self-weight values, you can go to visible load case. Okay, just click on visible load case. So here you have the self-weight, dead load, live load, and wind load. So the load cases that we created. Okay, so let's go to self-weight and then accept. Okay, so here you can see the self-weight in the yellow color. If you want to see it better, you can go to load, and here you have the scales. Okay, so let me click on scales, and I want to see them or scale up by 10 times. Okay, and then accept.
Okay.
Okay, so here you can see the loads. This is actually now for self-weight. So now is good time to talk about the hunches. Okay, so the thing that Mr. Fauzi asked me to show you. Okay, so I'm going to add the hunch, let's say, here and here for all the rafters. Okay, and you will see that how the software, yeah, how software actually calculate the self-weight of the rafters as well, or let's say, the hunches as well. Okay, so let's do that. So to add the hunch, let's go back to this view, YZ view. And I will go to bar, and here I have the describe option. Just click on that. And from here, just select the right side of the purlins. Since I have group, everything will be selected, okay? Here, the rafters. Okay, go to bar, describe, and then select the rafters. And then right click. So right now, whatever we have, it is a simple section, or let's say simple standard section. But if you want to change anything, so here you have the different options. You have the simple with hunch, with concrete slab, which means composite beam, double welded in box, double in box with bottom plate and top plate, double in box generic joint, half section with lateral plate, and also castellated or with opening. Okay, so you have different options to create. So right now, we want to add the hunch. Okay, so that simply click on simple with hunch. Here you have 4 options. Assume that you have this structure. So here you have the initial top hunch, initial or final top hunch. So initial top hunch, assume that this is the beam and the start joint of the, or here I will say that the start node, and here is end node. Okay, so initial top hunch, which means at the initial node, so it add top hunch, and final top hunch, final top hunch. Initial bottom hunch, which is here, final bottom hunch, which is here. So now we have the rafter. So for the rafter, here is the initial bottom hunch, and here for this, because this member is up to here. Okay, and then here you have the final bottom hunch. Okay, so it will create this one. So that's why I need to select the bottom one, initial bottom hunch and final bottom hunch. So you can go with the absolute manner, which is, you know, up to based on the meter, or you can go based on the percentage of the total length of the member. So let's go to the meter. So I want to have the 1. Let's say 8 meter at this location, at this location, and at this location I want to have 1.6, let's say. Okay, and that's why here I will say 1.6. Okay, 1.8, 1.6. So once you have this, and then you can accept it. So here you can see you have the hunch. If you want to see it better, you can go to render view. You can go to 3D view and then complete the structure. And as you can see here, so simply you could create the hunch. Okay, so I will close this. Now, once again, I will go to the load and visible load case. Again, I want to look at the self weight and then accept. You see here, so the software is able to calculate the weight of the hunch as well, and it will add to the weight of the member. Okay. So now let's go to other load type that we have. So far, I don't have any. If I go to visible load case, and if you change it to dead load, and then accept, as you can see, so there is no load applied as a dead load to the structure. And similarly for live load, okay, so accept. So no live load is applied, and also no wind load. So let's apply some loads. If you want to apply the load on the bars, okay, so here I have introduced load on bars, okay, which means member load. Okay, so you can click on that. So it can be under dead load or live load, whatever you have. So let me discuss something here. And I want to show you another advanced option. So if you remember, we said that here we have the 7, 7, 7, 7, 7, 7. And here I'm saying that, you know, this raptor, I will say that, you know, this raptor, I want to consider as raptor number 1, which is the external raptors. Okay, and so the internal raptors, so I will say that, let's say, you know, I change, so internal raptors. Okay, so if I want to apply the member load to external and internal raptors, so I need to calculate it, the thing that always you are doing in a StatPro. So here you have 7 meter, assume that, you know, our dead load is 0.1 kilonewton per meter square. So simply I can calculate the member load. I can say that 0.1 kilonewton per meter square times the tributary area. So here I have the let's say 3.5 meter, and here also I have the 3.5 meter. Okay, so 3.5 meter of the load, so we'll go to this rafter. So that's why here I will say 3.5, and then so it gives me 0.35 kilonewton per meter. Okay, but for internal rafters, so as you can see, so I have another 3.5, which means 3.5 from this tributary area and 3.5 from this. And finally, I have again 7 meter. Okay, so this is actually correct for all the internal rafters up to here. And then I will say that 0.1 times 7 equals 0.7 kilonewton per meter. Okay, and this one again, this one is, let's say 3.5, and this one also is 3.5, the external rafter. So if you want to apply this load manually, so I can let's say go to load, introduce load and bars. Okay, just click on that. And let's say, for example, this one. So you can select this, you can select, let's say, this Raptor and this Raptor, okay, the external one, and then do right click. So here you have different load type. You have the concentrated load, you have the fully UDL, partial UDL, triangular in different manner, trapezoidal, concentrated moment, constant temperature, and variable temperature. So let's go for example, UDL. And the way to apply the load, you have two ways. You have the global access and also you have the local access. So if you want to go for global access, so which means you need to consider this global coordinate system, okay? And if you want to apply in the, for example, global access in the Z direction, vertical one, so then you need to select this one, which is automatically selected, okay? And then so the load exactly will be like this, completely vertical, sorry, completely vertical. But if you want to use the local coordinate system, so if you remember here, you have the rafter, okay? And this is actually now X direction, this is the Z direction, and this is the Y direction. Okay. So then the load, if you select the local coordinate system, so the load will be applied in this direction. Okay, so this is the difference between global and local coordinate system. So let me go back. And here you have, let's say this three options, the second three options, okay, and the last one. So let me explain it in global coordinate system, is much easier to understand. Okay, if you look at this, you see here, this one, the first one is the direction of the load in positive X direction. Okay, and the next one in positive Y direction, and the third one in positive Z direction. Okay, so for the next third options, so you have the negative X direction, negative Y direction, negative Z direction. And if you want to apply the load in any other angle, so you can use the last one. Okay, but by default, the negative Z is active. And that's why here you don't need to put negative. Okay, just like a stat row. In a stat row, we put negative. But here, it depends on the direction that you are selecting. So by default, the negative Z is selected, which means the gravity. So that's why you don't need to put negative here. But if you select this one, positive Z, so definitely here you need to put negative value. Okay, up to you. Okay.
Okay.
So here we said that for example, this external rafters. So simply you can say 0.35. Okay, and then accept. See here, you have the 0.35. Okay, and similarly, you can select, the internal rafters and apply 0.7 kilonewton per meter. That's it. Okay, so now let me just, if you want to remove the load, also simply you can remove the load. So here, delete the load and bars. Okay, you can click on that, and you can see the load graphically can be selected. Okay, so you can select this load, and also you can select this load. Okay, once you select the load and then right click, it will be removed. If you want to apply the nodal load or point load, so here you have the option, introduce load and nodes. Okay, you can click on that and you can select a load type that you want to apply. And then here you have the nodes. For example, here you can select these two nodes and again, right click. So here you can apply it in the positive X direction, positive Y, positive Z, negative X, negative Y, positive Z, or any angle that you want. Okay, so I can, for example, here I have the Y axis. Okay, that's why I can go to positive Y. Okay, and then so the value is 9.81, accept. Okay, you see here, you have the load in this direction. So let me undo this one. I don't want to apply the load. Right now, I want to show you a more advanced option, which is here, okay? Introduce panel. So the panel load decompose or transfer the pressure load to the member load automatically. Okay, so let's see. So just click on introduce panel. Always again, you can read the instruction. Okay, so I'm repeating this, please remember that. Okay, so I can select from this node, doesn't matter, you can select any node. So I'm selecting this node, come to Apex, and then come to another, let's say, location of the roof, and then here, okay, and before closing again, do right click. Okay, so the software asks you select the distribution direction of the load. So I can accept this, and here you have the option. You see here in this location or in this part of the portal frame, purposely I didn't model the purlins because I wanted to show you the distributed load is in this direction to load the rafters. Okay, so we can load the rafters. But in this part, so the you have the purlins, okay, and then so you can load the purlins by using or selecting the direction of the load in this manner, okay, and then all the purlins will be loaded in a set of rafter. Okay, so now since we are in this create the panel for this part of the portal frame, so that's why I need to, and also the distribution is like that. I need to select either this line or this line, doesn't matter. Okay, select one of them. Just select. Okay, and then right click. Okay, and then close this window. Here you can see that the load is distributing in this direction. You did it?
Okay.
Yeah, please, once you're done, let me know. Done?
Can you repeat at the?
Sure, sure. So I will undo the procedure. So you need to go to load and then introduce panel. Okay, click on introduce panel. And here, so in the instruction at the bottom, it says that introduce panels, insert the points of the polyline. So I will select from here, okay, this point, and then go to Apex here, and another location of Apex here, okay, and then go to here, this node, okay, and before closing, just do right click, okay.
Yes.
Done?
Then.
Okay, so now, since we said that we want to load the rafters, okay, so we need to select either this line or this line. So I will select this line, for example, and then right click, and then close this window. Okay.
Okay.
Okay, great. So now let's create another panel at this part of the portal frame. So this time, you see, you can start from anywhere. Okay, so for example, this time I will start from this apex. Okay, so here, and then I will go to here, to this point. Okay, and then go to this point, and go to this point. Before coming back to the let's say the first one, do right click. Okay, so this time we want to load the purlins. So that's why, you know, the distribution direction should be like this. Okay, so that's why you can select either this line or this line. Up to you. Okay, so I will select this line, for example. Okay, and then right click and again close. So now you can see the direction.
Oh. Okay.
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 So now let's apply the load. Okay. So I want to apply the, here you have the edit load on panels. Okay, so just click on that. And here I will select, you know, these two panels. Just select these two panels and then right click. So you have this window. And for this window, so here I'm going to add the dead load, which is 0.1 kilonewton per meter square. Just click on that. And then here you have different load type that already you created: self-pay, dead load, live load, wind load. So I'm selecting dead load. And here the value, so I'm going to say 0.1. Okay, so you don't need to put negative. Okay, so you don't need to put the negative value because here it says that downward vertical. Okay. Okay.
Okay.
Okay, so here 0.1 and then accept. You see, I applied this load as a dead load. Okay, and then here you can see that the load is applied actually, you know, to the panel. Okay. But let's go back to load.
Introduce. Okay.
Let's go back to the load, and then here you have the visible load case. Okay, visible load case. Click on that. Yes, and then select the dead load and then accept. So now what you can see, you see here, you have the 0.35, 0.7. Okay, so all of them actually now will be calculated and transferred automatically. Okay, 0.7 and also 0.35. Okay, and for purlins, because we actually, you know, load the purlins, also you can read the purlin loads as well. Okay, so
Introduce payment. Oh, yang ada purlin tu klik horizontal.
okay,
Outback mula. Mana dah?
done.
Wait. Ni. Yang masa lain cara dia tu, awak kena klik mana ni, muka mana ni. Panel, enter the panel lah. Tak dia kotak awak ni lah. Okay, saya press. Tapi siap dah yang panel awak. Patutnya nak panel ni gini. Gitu. Oh, klik ni. Okay.
Done.
Panel awak ni. Ni. Oh, kan panel macam ni kasih. Ni. Okay, proceed. Okay, done.
Okay, great. Okay, so now similarly, I can add the live load as well. I will go to load again here, edit load on panels. Okay, again, select this and this panel, these two panels, and then right click. So I can add another load, let's say to this panel. I have the dead load, and next one, I can add the live load. Okay, and here I will add the 0.15, for example. Okay, so this is for live load. If you want to apply the wind load, you can go to the load. Here you have the introduce surface load. Okay, so I can go to introduce surface load, and I will change this one to wind load. This is the manual way of applying the wind load to the structure. But if you remember from the morning session, so I showed you how you can use the portal frame generator to generate the wind load automatically and export it to Cype 3D. Okay, but here I'm showing you the manual way. So the wind, and then so I will start, for example, from here, and then go to here, go to here. Okay, and then go to here. Okay, and before closing again, so I can do right click. Okay. Okay. So if you want me to repeat, so please let me know.
Okay.
Okay. So now you have this window.
Okay.
So you can apply the load. First of all, here you can see you have the direction of the load. Okay. As you can see, since you are applying the load in this panel, so the software automatically understands there is no load in the X direction, that way is 0, and there is no load in the Z direction, which is 0, only in the Y direction, which is 1. Okay. And so here you have two options. You have the uniform. You can apply the load uniformly, wind load uniformly, or it can be varied, depends on the height. So if you apply uniformly, so let's say, for example, the wind load is 0.45 kilonewton per meter square. Okay, and then accept. Okay, so once you accept this, so you can say that, okay, do you wish to create a panel associated with the new surface load? Yes. Okay, click yes. And then here you can see, so this is, maybe you can look at it from the YZ view. Okay, so if you go to YZ view, as you can see here, uniformly, this load, which is 0.45, will be applied to the structure in this direction. Okay, if you want to go back to load, and here you have the edit surface load. Okay, click on that, and again select this panel, and then right click. So this time I want to apply it, depends on the height. Okay, so the value at the top level, so I will say that 0.45. You can go for, okay, and then accept. Go back YZ view, you see, you can apply the wind manner. So you have the 0.1, and at the top you have the 0.45. Okay, so similarly, you can also create the surface load in this direction. So which means you can start from here to here to here, here, and here. Okay, so let me show you. So you can again go to load, and here you have the introduce surface load. So let's say we want to apply the load in X direction as well. Okay, so I will start from this point to here, and again here, and here, okay, and again here, and before closing, so just do right click. Okay, again the same thing. So here I will go to vary, depends on the height. So here at the bottom side 0.1, and at the top 0.45. Okay, and again accept. Yes. Okay, so here as you can see, the load is applying in this direction. If you want to change the direction of the load, you can go to the load, edit load and surface. So just select this surface, right click, and then change this one to negative, and then negative, accept. Okay, so here you have this load as well. Okay, so I can look at it from here. Okay, so this is the way to apply the wind load to your structure. Do you have any questions so far?
I cannot do the surface load at the
Self-weight will be calculated automatically. Okay, so you don't need to worry about that. It's not like a stat pro.
Okay.
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 Yeah, just you need to look at the, let's say, superimposed dead load, superimposed live load, superimposed load, and other type of load that you have, wind load, earthquake load, soil pressure, whatever you have. Forget about the self-weight because it will be calculated automatically.
Okay.
Any other question?
Okay.
No.
Okay, so let's go to analysis. Okay, so after completing your loading, the modeling, everything, okay, so I can go to analysis. So under analysis, so simply click on analyze, click on that. And then from here, so just accept. Okay, so I didn't talk about the buckling. You see, this window remind me about the buckling. Okay, so you see here I have the purlins and I'm not caring about the buckling because already I have the purlins and the stiffness of the purlin will be calculated or considered during the analysis and design of this part of portal frame. But how about this part? So in this part, I didn't create the purlins, okay? But I need to consider the effect of the purlins because in reality, I have the purlins here, but I didn't create them. So that's why once you did not create the purlins or any other member, but you want to consider the effect of that member or those members, so you need to go to buckling option. So this is a good, let's say, reminder. And that's why I recommend you to do not, let's say, check this option. Okay, so just leave it as default. Every time, let it remind you about the buckling. Okay, so that's why I will go to cancel. Okay, I want to talk about the buckling. So let's go back to the bar. And here you have two options. You have the buckling and you have the lateral buckling. So if you go to the buckling, so you can select, all these rafters, just like this, or I can go to this view. Okay, I can select all these rafters, which I don't have the purlins there, but I want to consider the effect of purlins because I know in reality there is purlins. So once you select this, let's say members, as you can see, if you a little bit zoom in, you can see that XY and XZ factor is 1. So let's a little bit talk about the, let's say, planes. So here in Cype, you have the Y-axis. In any software, the axis parallel to the axis of member is X. Doesn't matter, Stat Pro, ETAP, SAP 2000, or let's say Cype, Proto structures, any software. Okay, and the last one here, it is the Z-axis. So in Stat Pro, the place of Y and Z is opposite. Okay, so in Stat Pro here, you have the Z-axis and here you have the Y-axis. So now we have two main planes. So maybe I can go for XY plane. So this is the, let's say, XY plane. Okay, and I have another plane, which is XZ plane. Okay, so this is the XZ plane. So if you remember from our, I don't know, structural analysis, so here we have the Y-axis and here we have the Z-axis. Okay, and always actually, the moment of inertia around the y-axis actually is bigger than moment of inertia about the z-axis. So that's why we said that, you know, the y-axis, so the y-axis is the strong axis. Agree?
Yes.
Or we call it major axis. Major axis. So here also we have the same thing. Look at the beam. So here I want to create the beam once again here. You have the beam like this, okay? And here you have the y axis, and here you have the z axis. So by the way, here also the z axis is the weak axis, weak or minor. Okay, so if you look at the y axis, you see here you have the let's say here xy axis. So this xy axis is the let's say major axis, which is actually, you know, it happening the, or let's say the moment happening around this plane. So this is actually, you know, major plane. Okay, so we are not anymore thinking about the axis. We have the plane. Okay, and this one is the minor plane. So once we are talking about the buckling, assume that here we have the purlins at the top of this rafter at each 1.2 meter, right? So the purlins, once we have the purlins, let me just create this one. Okay, so let's say here we have the purlins and it is in this direction. Okay, so we have actually, this is also in the y-axis direction. You see here, it is in the y-axis direction. So let's assume that this is the y-axis direction. And then, so in the y-axis direction, you have the restraint. So which means, you know, the effective length will become something like this. Okay, but if you don't have this axis, or let's say, you know, this purlin, sorry. Okay, so the deflection will be like this, right? But once you have the purlins, so the deflection will be like this, right? So that's why we call it this one as effective length, or LE. Okay, and this effective length is 1.2, and here you have the y-axis, okay, and here it is the, here it is the z-axis, okay, and then so this is the x-axis. So this restraint is perpendicular to the xz axis, which means here, perpendicular to this plane, which is the purlins is in this direction, right? And this is perpendicular to xz plane, right? So that's why you need to change, or you need to select the xz plane and specify the effective length. Okay, so that's why here I will, let's say, clear everything and then go to bar, and here I have the buckling. Okay, just click on buckling, select, you know, for example, all the rafters, but for training purpose, I'm selecting these two rafters, for example, and then do right click. Okay, and then here you have the buckling length in XY plane, buckling length in XZ plane. So here you have the, you know, some standard values according, you know, to the our textbook that we passed in university, and based on the condition that you have, the end condition, fix, free, let's say fix, free, or fix, pin, fix, free. Okay, you have different buckling factor. Or maybe you can go to buckling factor, any buckling factor that you calculated, you can key in here, or the easiest one, you have the effective length. Okay, since here we know that, you know, the distance between the purlins are 1.2 meters, so that's why simply you can come to effective length. But here, so we are not going to apply the effective length in XY plane, because here we said that this is actually, you know, perpendicular to XZ plane. not XY plane. Okay, so that's why I am not caring about this. Okay, I'm not caring about this. And from here, in the XZ plane, I will go to, let's say, LK. Okay, and then length, I will specify as 1.2 meter, and then accept. So here you can see in the XZ plane, so you have the 1.2 meter. So another value for the one that you have, it is because of this equivalent uniform moment factor, CM. Okay, which means, you know, the transferring of the moment from, let's say, purlin to rafter. Okay, so this is actually, you know, the way that you can apply the or define the buckling factor or effective length. Another option that you have, which is simplest one, so you can go to lateral buckling. Okay, and then from here, for example, this rafter, I can select on that. And here, as you can see, so you have the top flange and you have the bottom flange. So you can tell the software, for example, here, you have the restraint at top flange. So then here you can go to LB or effective length. Okay, and here you can see the separation between bracing 1.2. Oh, and again, equivalent uniform moment, CM, can remain as 1, and then accept. So here you have it. Okay, so you have two options for assigning the buckling. So once you assign the buckling to all necessary rafters that you need to do, so then you can go to analysis once again. So I'm going to analysis, accept. Again, this is reminding me about the buckling coefficient. I will accept now. And once the analysis is done, the software gives you some information related to analysis and design. If you have any warnings, if you have any extra information, so the software gives you. For example, here, the software says that the fire check options had not been activated. So we know about this, correct? Because purposely we didn't activate the fire situation, if you remember. So that's why, just again, the software tells you that maybe, you know, as a reminder, so you can go back and assign the fire situation as well. But I'm not going to do that. And then close this. Okay, so once you have this, I can go to analysis, and under analysis tab, so I can get all the information that I need. For example, displacement, I can click on displacement. So usually displacement and deflection can be checked under SLS, serviceability limit state. So that's why here you have the, let's say, different load cases. You have the simple load case. Okay, so let me just click here. You have the simple load case. Under simple load case, so you have the self-weight, you have the dead load, you have the live load, and also you have the wind. So the next one is the displacement, which is SLS. Okay, and the rest from here to here. So you have the ruled steel, cold form, timber, aluminum, and concrete. So they are ULS. Okay, so it means for designing the ruled steel or cold form or timber or aluminum or concrete sections. Okay, so it depends on what kind of structure you have. For example, our structure mainly actually made of ruled steel. Okay, and if you look at the, for example, most of the codes, so the combination for example, cold form and ruled section are almost same. Okay, so that's why here, for example, if you want to check the forces, for example, moment or shear or axial force, so you can select the ruled section. Okay. So since we are checking actually, you know, Since we are checking the deflection, so I can come under displacement, okay? And as you can see here, the load combination will be generated automatically, okay? All with factor 1. Okay, so we didn't do anything for SLS or ULS, but the software automatically generated according to selected. Okay, so I will go to the last one. So I want to check the displacement under this, or you can go under envelope. Okay, so up to you. So let me go to under this load case, under displacement or SLS, and the last option. And then I want to look at the column, for example, displacement. Just click on that. As you can see at the base, since I have the fixed support, so there is no displacement, no rotation. But at the top, you have actually, you know, displacement in X, Y, Z direction, and also you have the rotation about the X, Y, Z axis. Okay.
Okay.
Okay. And once you want to hide the displacement, once again, click on the column. Okay, similarly for the beam, for example, here, I can click on this beam and then you can see the displacement. Okay, and again, click on the beam to hide the displacement. So let's go to another option, which is reactions. Okay, just click on the reactions. Again, usually reaction can be considered under SLS, displacement. And again, so I will go to select this one. And from here, simply I can click on this, maybe this one, maybe this one, and maybe this one. Okay, so you can select, actually know what joint you want to see, or maybe you can go to, for example, here, top view, and you can see the reactions. Okay, so another option that we have is the forces. Okay, you can go to the forces. And you can see the forces for all bars. Okay, for example, I want to see the axial force. Okay, just click on axial. And as you can see here, so you have the axial. Maybe here you can scale up 0.1 to 0. For example, 3. Okay, and then so you can just click somewhere and then here you have it. But this one is under self-weight. Okay, again, so for forces, we can go to ruled steel, which is ULS. Okay, so I can click on this and you see here, you have all the, let's say, ULS combinations. Okay, so I can go to last one, for example, and as you can see here, you can see the axial force. And similarly for the moment, you need to go to MY. Okay, so in a StatPro, usually we check it under, let's say MZ, but here you need to check it under MY. Because I told you, so the Y and Z axis is different from Cype and StatPro. Actually, StatPro is the only software that Y axis is off. Yeah. Okay. If you want to see the values, so here I have the moment, and then here I have the display values. Okay, so here you can see the values as well. Okay. Okay, so if you go to envelope, so let me just, if you go to envelope, here the last option you have it as stress or DC ratio. Okay, so this is actually, you know, the utilization ratio. So my friends, are you with me? Okay, so if you go to the envelope, and then the last option here, you have the stress or DC ratio. This is actually the utilization ratio. And from here, you can understand, so which member is failed, which member is passed. Okay, so here you have the legend, from 0 up to 1. Okay, and from here I can see that this purlins already failed. You see here, these purlins are failed. Okay, and also I have some big stresses for these columns. Okay, and also from deflection you can look at the deflection, so you can decrease the, let's say, the scale. Okay. The total deflection. You can look at the deflection in XZ plane, XY plane. Okay. So in this case, you can review the, let's say, result. Okay. So let me go to another option. Go to analysis. Here you have the deform shape. Okay. Go to deform shape. Here, click on deform shape. So from here, again, you can see that the maximum displacement or deformation is about 15 mm, but under self-weight. If I change it to displacement, and then here under this, as you can see, so you can also decrease the scale. Okay, so for example, here I can decrease it to 4, for example. Okay, and again here you can see that you have a huge displacement, okay, which is about 1 meter. Okay, and if you go to animation, so here you have the animation, this small icon, this is the animation. Okay, click on that, and you see this one is because of the X, or wind in X direction. So it is a huge surface, and we apply actually the wind load in this direction. So and that's why you can see that the structure is moving by 100, or let's say 1 meter. Okay, so I will close this, and also I will close this. So let me show you another cool option. Go under analysis, and here you have the check elements. Okay, so click on that, accept. So here you can see the red colors, which means failed, and green colors, which mean passed. So right now I have some of the columns failed.
Analysis.
I can come to just put your cursor at the top of this columns. So look at the utilization ratio or resistance ratio. It is 142. Okay, what about this? It is 130, 102, 110, and so the critical one is this one. Okay, it is 142. So I can click on this member. You see, you don't need to rerun the analysis and go through the manual process, again and again. Okay, and here it gives you all the utilization ratio. Okay, so for example, right now the section that we are using is this one. Okay, the software asks me, okay, so why you are not using, for example, this member? Okay, so you can use this. Okay, and then utilization ratio will become 74. Okay, so I will accept this. And since already I grouped the columns, so this will be applied to all the columns. Okay, let's say accept. Okay, and this, you can see here, so this member passed. Okay, but this one passed actually for this one, and also here I will go to select the same, let's say, section for this one as well. So you see all the columns passed. So this is actually one of the big advantage over other solutions that you can get from Cype. So look at this, let's say members. This is 197, 200, okay, and then also 200. So let's go to this one. I will click on this member. And again, instead of using this, so I can use this one. Okay, UB 203, 133, 30. Okay, and then accept. You see, simply you can just by 2 clicks, let's say pass the sections. And then here, so you have the 351. Okay, so it is huge, let's say utilization ratio. Okay, so I will click on this member. And here the software says that instead of using the current section that you are using, which is C80, so you need to use this one. Okay, C140. And the utilization ratio will become 89. Okay, and if I accept this, you see all the purlins will be passed. Okay.
Okay.
So this rafter also I have, it says that the interaction between torsion and shear cannot be checked due to the tangential torsional stresses are excessive and cause the section to fail. Okay, so I can click on this rafter. Okay, so here also the software gives me other solutions. So I will go to this one. Okay, UB 610.229.101 and then accept. Okay, so everything passed. If you want to look at the structure once again, because we changed the sections, you can go to render view, and this is actually the structure that you have. And you see, simply you can pass the design. So once you change the section, so you need to reanalyze your structure to redistribute the stiffness of the members. So that's why here I will go to analyze once again. Okay, and accept. Okay, and once again, I will go to check elements, accept. As you can see, everything is passed. Okay, so in this way, you can simply pass these sections. So if you want to look at the step-by-step calculation report, under analysis, here you have the ULS check. You can go to this option, and let's look at this column, for example. Just click on that. And here you can go to view the complete listing here. Just click on that. And it gives you all the necessary information about the section, material, I don't know, about the mechanical characteristic, lateral buckling, nomenclatures, and everything is here. Do you like the report?
Yes.
It's very tidy. Okay, so I will close this, and let's look at this, for example, rafter. So I will click on this, and again, view the complete listing. So you see also the hunch is here. Okay, and also here you can see that UB blah 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 simple with hunches. Okay, and again, so here you have all the step-by-step calculation report. Okay. So once you did this, you need to design the connections. Okay. For designing the connections here, you have the joints. Okay, you have two options. You can go for manual way, which is new, or you can go for automated one. Okay, so here generate. Okay, so I will go to joints, and then here I have the generate option. Click on that. So the software asks you, do you want to group the typical connections? So the software again is smart enough to understand the typical connections. For example, here I have the typical connections. Okay, and for the rafters here, also I have another typical connections. So here I have another typical connections here, 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 and here. Okay, so the software understands this. Okay, and simply I will say yes. Okay, so 35 connections have been generated, accept. And as you can see here, everywhere you have the connections. So if you want to review the connections, you can go to joints, and here you have the edit option. Okay, you can click on edit, And let's say, for example, here, I want to go to this base plate. Okay, just click on that. And here you have it, but still it doesn't, or let's say it hasn't been designed. So you can go to this option. You have the base plate, you have the stiffener, and also you have the bolt. And this is small icon. It is the edit options. Okay, so for example, for the base plate or bolts, let's say go to bolts. Okay, so I can go to the bolts. And from here, I want to assign the bolts with the simple washer and the number of bolts in each direction. For example, let's say 2. Okay, and also in the Y direction, I want to make it as 2 and then accept. Okay, and as you can see here, so I can create the, let's say, base plate. But the easiest way here, you have the smart design option. You see the small hand icon? Just click on that. Okay, so it automatically suggests you the best solution. And again, for the connections, also you can get the, let's say, a step-by-step calculation report. Okay, and once you have this, so here you have it actually here. Okay, so this is actually now for base plate. And then so you can accept it. You see all the base plate will change to green color. Okay, so let's go to another connection, for example, this one. Okay, so you can click on this connection. So as you can see, this is the connection. And then again, you can go to a smart design option. Just click on this. So here you have 3 options. You can go for welded connection, you can go for bolted connection, or you can go for a specific method. So for example, here you have the rafter and you have the tie beam. Maybe you want to connect the rafter as the welded connection, but you want to connect this tie beam as the bolted connection. Okay, but let's go for bolted connection. Okay, just I'm selecting the second one and then accept. Okay, and then yes. You see here again, you have the all the step-by-step calculation report for this connection. Okay, so you will get all the calculations, and then here you have it. Okay, you see here you have everything, and then you can accept it. And again, so as you can see, so this connection and this connection, the software consider as typical connection, and this one also is done. So before generating other type of connections, so let me show you the drawing. Okay, so here under file, you have the drawings option. Okay, so you can go under drawings. And then accept. So here you can click on this add button. And here you have the joints, the second option, joints. And then accept. And again, accept. Okay, so here I just created actually for design 2. So that's why here, first you can look at the base plate. Okay, you have the base plate. Okay, and also you can look at the another connection that we created. So whatever connection you design, so will be added to drawing as well. So how is the drawing? You like it? Okay, if you want to, let's say, export the drawing to DWG, so you can go to print all. Okay, you see here, you have the print all. You can click on that, and then here you can save it in any folder that you want, and the drawing will be generated as DWG. Okay, and then you can accept it. Okay, so let me close the drawings. If you want to, let me go to tools and then 3D view, complete the structure. I want to show you something here. So you see right now, the components of the connections will be added to the render view as well. And here also I have this one. You see? Okay. But if you look at here, if you look at here, you see there is no connection still. Okay. So here there is no connection. Here there is no connection. Still no connection. Okay. And here also I don't have the bolted connection. You see here, I don't have the bolted connection. So, and this connection also is not right. You see here, so there is no plate. Okay. So let me show you the automated way. I can close this. Under analysis, so here you have the joints. Okay, and then here you can tell the software to design all the connections or joints. Just click on design. Okay, and then here, so I want to have them as bolted connection, all of them. Okay, the second option, and then accept. You see 35 connections, will be done just within 5 seconds. Okay, and then you have it. So let me take you once again to render view. So first we can look at the apex. See here previously what we had and right now what you have. See? Do you like it?
Yes.
Compared to a Stat Pro, because you're familiar with the Stat Pro, yeah?
Yeah.
It's much easier, yeah? And you see, it gives you also, a step-by-step calculation report. The Stat Pro doesn't provide us, that level of, let's say, report. Okay, so the connection done. So you already did. Okay, you see here, everywhere you have the connections. Everywhere.
Mr. Khalid,
Yes, please.
for the drawing.
Excuse me, I didn't get you, Mr. Razir. Could you repeat again?
For the output drawing,
Okay.
can we change the scale?
The change the scale. Okay.
Scale.
So let me show you something here. So I will go to the here also you have the drawing shortcut. Okay. Or you can, as I showed you, you can go under file and then you have the drawings. So let me go to here. Yeah, you can do the scaling as well. Okay. So here I have the joints. If you go to edit option, here you have the edit. Okay. And then so let me first generate this.
Kalau sini okey, kalau aksi macam bing dia untuk semuanya.
Okay, so you have all the connections, typical connections. And if I go to, let's say, edit objects, this one. Okay, so here let me once again, but this one.
Oh.
So So for the connections, let me check this one. But for other drawings, yeah, definitely you can scale them. But for the connections, let me check.
Tapi dia dah lagi. Dia dah lagi kat seterusnya.
For the connections, let me come back to you. But for other, for example, GA drawing or column drawings or beam drawings, if you have the concrete columns, concrete beams, so you can definitely change the scale, okay? But once again, let me just go to the drawing, show you at least for other type of drawing that you have. For example, here, I can go to 3D structure, okay? And from here, I can go to layer visibility. By the way, here you have different templates, so you can use these templates, whichever actually is close to your drawing style, okay? And you can set them as your default drawing template, okay? So you have several templates here. And also you can bring your title block as well. So here you have the scale option. You can see here, you can go for 1/100 or 1/20 or 50, whatever you want, okay? So, and also for the joints, okay? So if I go to the joints, so here I cannot see actually, the scale for the joints, but later maybe I can search about it, okay? I will let you know.
Okay,
But
okay.
but for the rest of the drawing, yeah, definitely you can go to configuration and you can scale them. Okay, so after finishing with connections, so now we can go to the foundation design. You see here, you have two tabs. You have the structure tab and you have the foundation tab. So a structure tab, which is actually for superstructure, and foundation definitely is for substructure. So I can go to foundation. You see, you have the column layout plan. And from here, if you want to create the foundation manually, so you can go to foundation elements. And then here you have the new option. By the way, also you can bring the drawings if you want, okay? So still you have the option to bring the drawing, especially once you are working on existing structure. Maybe you are working on strengthening a project or strengthening a structure. Okay, so you can bring the foundation layout. Okay, let's go to foundation and then go to new. So if you want to create the isolated footing or pad footing, so the first option. If you want to go for mass concrete footing without reinforcement, you can use this one. Pile cap, you can use this one. And also you can go for, let's say, foundation beams using these three options. Okay, and if you want to do the combined footing, I will show you. So let me go to pad footing. So the first option, pad footing. As you can see here, you have different pad footing. Okay, so let's go for the first one. Is the most common one, accept, and simply you can let's say just click on the, let's say, column base. Okay, just like this. Or you can do right click if you want to make it as a combined footing. So here you have the with a single start or with a multiple start. Okay, so you can go for with multiple start if you want to create the combined footing. Okay, and for combined footing, so I recommend you to use the rectangular section, not let's say square sections, because the square section actually give you a very big section. You see here, if I select the square section, And then, so for creating the combined footing, so you need to select, for example, this column and this column, and then do right click. So once you did right click, so you have this small circle between these two columns. Just click on that circle. Okay, you see here, you have a very big footing. I can go back to, let's say, pad footing, but this time I want to select the rectangular footing. Accept. I will click on this, right click, and then click on this. Okay, so here I have the combined footing. So if you want to have the pile cap, you can click on pile cap. You can select the pile cap with pile configuration, for example, with 3 piles. And before starting the modeling of pile cap, so you need also to specify the pile characteristics as well. So for example, here, select pile, you can add, as you can see here, you can say that, for example, pile type 1, the type can be circular or square. And also here you have the capacity of the pile. So let's say vertical capacity, for example, I can say that 1,000, and also seismic and accidental situation or under seismic capacity. Also, I will say that, for example, let's say 1,000, okay, just for demo purpose. And minimum distance between axes of the piles, so you can specify from here. And also you have the penetration of the pile into pile cap. So here you have the option. Once you are satisfied with this, so you can go to select any pile cap configuration, so, and then accept. So you can also override the pile cap with the existing footing. Okay, just like this. Also, you can go to add the tie beam or strap beam or beam with automatic balancing at the ends, which is kind of a foundation beam. Okay, so let me go to, for example, a strap beam. Okay, it doesn't matter, so I can accept. And then, so I can go just like this, or I can just go like this to here and here. The software automatically understands the rigid zone of the foundation. You see here, or you can go from here to here. So you are completely free, you know, to do whatever you want to model. Okay, so just like this. Anyway, so once you created this, so you can, let's say, check the foundation. For example, you can go to analysis, and then here you have the check option. But let me delete everything. So I want to delete everything. Okay, so here you have the delete option, or you can under foundation, here you have the delete. You have also foundation wizard. Okay, so under analysis, here you have the generate footing and beams. So the software come up with the best suggestion for us. Click on that. And then here it says that, do you want to create the foundation beam? I will say yes. Okay, and that's it. So here you have it. So once, this is actually the configuration of the foundation, but you need to design it as well. If I go to, let's say, edit, under foundation, edit, okay, I can click on, for example, this foundation beam. You see here, you have the information for this. You have the, you have the selection, you have the stirrups, you have the anchors, and also you can go for code check. Okay, if I click on that, you see here, I have some warnings, which is related to maximum stirrup spacing. Okay, so again, so here you have the smart design option. You see here, design. You can tell the software to design for you. So for example, here we have, let's say, stirrup with the 12, and at each 700, at each 30 or 300 mm. Okay, so I can tell the software to design for me. Okay, and you see here, so it will be updated with 25. Okay, and also here, yes, please.
Can we change cm to mm?
Excuse me?
Change cm to mm.
Here is not possible. Okay, but in the drawing you can do that. Yes.
Okay.
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 So we can actually, just do like this, and then from here you can also see the 3D view using this option here at the bottom. Okay, so here you have the 3D view. And also for, let's say, pad footing, for example, here, I can click on this pad footing. Again, here you have it. You can change the material, geometry, reinforcement, options. Okay, and again, you can go to code check. Okay, and as you can see here, so you have completely an error. Okay, but you can again tell the software to design for you. For example, here, and it is very clear because we have actually, the base plate anchors because, it is out of foundation, yeah. And right now, as you can see here, it is 300 mm or 30 centimeter. So let's go to a smart design option that I have here. Just click on smart design option. Just click on that, accept. You see here, automatically will update it. Okay, and again, if you go to code check, you see everything is passed. Okay, and then you can save it. Okay, you can accept it. You see this one is updated. But maybe you have actually, several foundations. You don't have time actually, to go through them one by one. Okay, so before showing you, the smart one, so let me go to render view. So here again, you have the render view. This is a small cube that you have here. You see? So if you click on that, you see, for other footing, so this is actually, the anchors are out of the footing, but for this one, is already done actually now by the software. It's fine. And also, if you go to elements, remember at the beginning of our training, we had only columns and beams. But here, just like AutoCAD, whatever you're adding to your structure, so the structural layer or layout will be updated. Right now, I have the steel column, steel beam. I have the joint, which means, welds. I have the, let's say, what is that? Let me just make it bigger. Okay, so you have the carried out in situ welds, workshop weld, plates. Okay, and under base plate, you have the base plate, anchor bolt, hunch, bolt, nuts, washers. Okay, and also foundation. So here you have the putting, concrete reinforcement, and also concrete beams, concrete reinforcement. So if I go to foundation, for example, here, I want to see it just like this, or maybe in the transparent view, just like that. Okay, so let me close this. So right now we actually know what is the reason for this failure because of this anchor. Okay, so I will go to analysis, and here I have the design option. So again, I can tell the software to design all the foundation, at one shot. Just design, and you see everything will be updated. Accept. Okay, you see here everything updated and designed. So once again, if we go to render view, you see here. So now everything is perfect. Okay, so let me close this. I can also go to the drawings once again. You see here, I have the drawings. Again, whatever components you are adding to your structure, so they will come under drawings as well. So right now, if you remember previously, only I had the 3D structure and also I have the joints. But right now, if I click on that, you see here, I have the foundation floor plan, and also I have the foundation layout plan. Okay, so you can also, let's say, introduce this one. And again, here you have the scale, as you can see. You can go to configuration. So here, you can, let's say, just update the drawings. For example, under columns, you want to see the column as field, okay, and elevation of the column, dimension of the column. For example, you can go to footing, pile cap, and beams. So here you have different options and also a schedule. So you can just, let's say, add these options, okay? And also reinforcement layout. So here you can add them, and the quantity summary also you can generate, okay? And then accept. So you can also uncheck this option, just you want to see the, for example, foundation drawings. Okay, so here I have all the information for foundation as well. Okay, so right now here you have the let's say dimension with centimeter, yeah. So here I think this one is with yeah, it's still with centimeter. Okay, so if you want to change it to millimeter,
Never see that other one.
so let me check first from here. Okay, so if you want to change it to millimeter, so you can go to let's say project. Let me go to structures, okay, and then here I have the project, and here I have the dimensioning units. Okay, if I click on that, so the dimensions reinforcement can be shown as millimeter, okay, the length as meter, and also dimension with millimeter. Okay, accept. So the option is here under project dimensioning units. So let me regenerate the foundation drawing to see if you have the millimeter or not. Okay, so it still is 60. Let me check the units. Just give me a second, please. Okay, let's try. And check. footings. Okay, for this one, maybe I can come back to you. The text drawings. Okay, I think it's here. For this one, let me come back to you, Mr. Azir. So I will let you know. Okay, so right now I cannot find actually where is the option. Let me also try. So I will come back to you on this, changing the centimeter to millimeter for the drawings. Okay. Yeah, so don't worry about that. So there is an option. I will just show you.
One more. Can we use rough foundation?
Rough foundation, as I told you. So you cannot do it here in Cype 3D. You see here, if I come to foundations, so here the type of foundation that we have is pad footing, and also you can go for combined footing. You have the pile cap, okay, and also you have the foundation beam. If you want to do the foundation, or let's say rough foundation or matte foundation, so here let me show you. But this, we can continue on next session, okay? So here you need to use the Cype CAD.
Oh, okay.
Okay, so let me open it up. I will show you. Okay. Yeah, under Cype CAD, you can design, let's say, different type of foundation, including raft, mat. Okay, and okay, you see here, for example, here I'm in the foundation level, okay, and here I have the raft or mat foundation. This is actually now the raft or mat foundation. And also, if I go to render view, okay, so you see here, I have the raft foundation. Okay, and also it can be designed. Here you can get the reinforcement as well. If I go to result. Okay, so here I can look at the, let's say, reinforcement. I'm not sure this is done or not, but maybe yeah, so the analysis is not done. Okay, and also from here you can bring the Cype 3D model to CypeCAD, integrated 3D structure. If you click on that, you see here you can introduce the new structure, or you can import the job from Cype 3D. Okay, so I will cover it in CypeCAD training. Any other question?
No, okay.
Okay, so that's it. And if you want to generate the report, so you can go to the file, and here you have the report. Okay, so just click on that. Okay, accept. And simply from here, for example, I can uncheck everything. So assume that we want to generate the quantity summary. Okay, just click on that. Here you have the quantity summary, and then accept. And then so here you will get all the quantity summary. Or maybe you want to, for example, get the, for example, the result. Under result, maybe you want to get the under note, you want to get the reactions. Okay, so you can go under combination or under envelope, so up to you. And then so here you can generate it. Okay, so here you can get the reactions. Okay, so in this way you can just go ahead with selection and generate the report. Okay, so you have the information for the joints or connections, and also for foundations. Okay. So I think that's it. And if you have any questions, so still I'm here to address your questions. Otherwise, we can end up the session here, and we can arrange another session for CypeCAD, and we will cover the, let's say, shear wall design or any other requirement that you have.
Okay.
So, any question?
No.
Okay, great.
No
so,
question.
Don't worry, if you have any question later, so just WhatsApp me, okay?
Okay.
And please, please work with the software. I believe that this software actually now can make the process much easier for you compared to other solution that you are using. And just for your general information, we have, let's say this is kind of thing that I don't want to record.